Here is my simulation for my Datapath state machine. So first we have our shift register, and it has the ability to load the input and an input value, shift the contents of the register to the left and clear the contents based on what is taken from the finite state machine as far as the selector output. So here we see that we have our inputs, and it's a clock, a clear, and an enable. And the enable is important because when the enable is on, then we are holding our value. When the enable is off, then we are going to be doing one of the instructions given. So here we see that when the clear is on, it's going to clear the register. When the clock is on and the enable is on, it's going to hold the value. And then when the clock enable is off, then if the selector value that comes from the FSM, which is a finite state machine, is 0, 0, it'll load whatever input value is input. And then if it's 0, 1, it's going to shift those contents to the left. And then when others, it's just going to hold it. So then we go to our counter. And our counter has the capabilities of incrementing and decrementing the value of the register. And so we have a clock, a reset, and enable. These are going to be tied to the same clock, reset, and enable as the finite state machine and the shift register. We have a selector value, which is input, as an input, which is output from the FSM, and then we have our counter output as well. And so what we have here is, when the reset is on, our clock, our counter will be set to 0. However, when the enable is on and the clock is on, then our current value is going to hold. When the enable is off, we're going to have a select value, and it's going to choose whether you want to increment it or decrement it. So if it's 1, 0, it's going to increment. If it's 1, 1, it's going to decrement. Here, if we look at our FSM, we are going to have a clock and a reset, as well as a select value, which is going to be the output, which is going to be used as an input for the shift and the counter. So for our FSM, we have the reset. When reset is 1, then the current state that we're going to be in is going to be the state 0. And when the clock is on, the current state is going to be the next state, equal to the next state. So then once we go to the actual finite state machine, when we're in state 1, we're going to send a select value of 1, 0, which is going to satisfy our counter, which we see here as it's going to increment 1 time. It's going to increment 1 time and then go to the next state. And then the next state, it's going to, right here, it's going to send out the same select value so that we're incrementing twice, and then go to the next state, which is going to be state 2. So once they're in state 2, the select value will be sent as 1, 1, which we know to be to decrement something. So the register should decrement at that point in time, and then go to the next state, which is going to be state 3. In state 3, we're going to send out a 0 to the select value. And if we look in the shift register, 0, 0 is to load. So whatever input is used as input, it will load into the register. And then after that, we're going to go to state 4. Sorry about that. So once we perform the shift 1 time in state 4, we're going to go to state 5, and we're going to repeat the shift again. And then we're going to return to the current state of 0. And when others, it's going to be 0 as well. And so here's our top module that connects all of these things together. We have a clock, a reset, an enabler, and then the input value, as well as an output for your shift and an output for your count. And then you create the components for your shift, your counter, and your finite state machine. And you create instances for them and port map them. Then we're going to have our test bench, creating a component for your top module. And so you're going to have a clock, a reset, an enabler value, and then your output for your shift and your your count, create signals for these and instantiate them to 0, and then create your component. We'll create your DUT test and port map it. Then you want to have the correct frequencies for each one of your stimulus to make sure that you get the right values. So when we come over here to our waveform, we see that, you know, it has an input, but once we start, we're going to start in it. What our register first does is going to clear, it's going to clear both our, here's our input value of 1010, our clock, our enabler, our reset, and our shift output and our count output. That just shows the shift register and the counter as two separate entities being brought together. So they are both cleared, and this is when the reset is on, so they are simultaneously cleared. Then once it goes to the first state, it's going to increment our counter. It's supposed to increment our counter twice. So as you can see, it counts it once and it counts it twice. So we can see here that that's working correctly. Our counter is being incremented twice as it should. And then it's supposed to decrement once it goes to the next state once, which it does. And it goes to 1 after being at 2. Our next thing is for it to load. Once it go to the next state, then the shift register should show a loading of this value of 1010. So when we move next over, we should get 1010, in which we do. Once it does that, it should make a shift to the left 2 times. And so our first shift, we see there, and then our second shift, we see, and this is what we get. And once we have our second shift, and then it resets again, and both are reset, and that shows